And we are now recording. I will get this posted this afternoon. Hopefully it'll be a little quicker because of the internet problems I had last week. It took me like 4 hours to get the video uploaded to YouTube. So anyway, all right, welcome everybody. We're going to go ahead and get started because I know that you guys probably have things you'd rather be doing than sitting here staring at a video screen at 10 o'clock in the morning.
I have my final case presentation this afternoon.
Oh, yeah?
Yep, they bumped it up a day on me last night at 9 o'clock. They emailed, can you do it tomorrow instead of Wednesday? I was like, sure, I'll help you out.
Awesome.
So,
well, then we definitely want to make sure we can get in and out so that Chris has all the time he needs to prepare. So a couple of things. I want to remind you, well, first of all, the test last week, generally everybody who went back in and took it a second time did much better. I know of one person I won't indicate, but because they're here and I don't want to embarrass them, but their first test wasn't so great. They went back a few hours later, took it a second time and did a fantastic job. So very happy about that. I do want to remind you a couple of things. One, your next test is on the, was it the 28th, I believe? You have another one of those tests similar to what you already took. It will be online. It will be in the same format. You'll have the same time frame. You'll have 2 opportunities to take the test and so forth. Then I want to remind you about your final exam. Now this is important. Your final exam is written. What will happen is I will post it in the file section on the day of the exam. You'll need to print it out, do the exam, and then you'll need to find some way to send it back to me. Ideally, if you have a scanner, if you have a printer with a scanner, that would work as well. Ideally, you would scan it and send it back to me. Worst case scenario, if you have to take a picture of it with your, a bunch of people just joined, so I'm talking about the final exam. Ideally, you would scan it and send it back to me. If you have to take pictures of each page with your phone and send me the individual images, it's not ideal, but if that's what we have to do, that's what we'll have to do. But you'll need to make sure that those images are very clear for me so that I can grade them. So that'll be for your final in May. All right. Like I said, a few people just jumped on, so I want to go ahead and grab those folks, make sure that I write down that they're here. Braden. All right. Jason just jumped in. Okay. So we are going to go ahead and get started because ideally, since I'm doing all the talking and you guys aren't, you know, giving me direct feedback constantly like we would in a class, it goes a little more quickly, and I want to honor your time. But I do want to remind you that if you have any questions, you can unmute yourself and just say, oh, Mr. Becker, got a question. You can also click at the bottom of your screen. There is a chat box that will appear, and you can type your comments in the chat box as I just did. Everybody should see that if they have their chat box open. All right, so we are going to talk about sections 12.1 and 12.2 today. I am going to share the notes. Oh, before I do that, just a couple of reminders. I'm sharing my screen, and you should be able to see Canvas. I want to remind you that to the left in the menu, there is a button that says Modules right there. And if you click on that, it will open up what we're doing on a daily basis. And so today, April 14th, we're going to do sections 12.1 and 12.2. There are a couple of PowerPoints that you could use as a resource. There are also a couple of videos that have been printed out, and those videos are not keyed specifically to the book. They're keyed to the content that we're going to talk about. Again, these are just additional resources for you to use. You are not required under any circumstances to use them, but if you need a little bit of extra help, they are there. So that's what we're going to do today is 12.1 and 12.2. On Thursday, we're only going to talk about 12.3. Probably be a little shorter class on Thursday, but it's important. There's some important content there that I definitely want you to be uh, around for.
Can I jump
Excuse
in
me.
real quick here?
Yes.
Actually, Thursday, I will not be having my session. I will not be in class. I have an all-day Zoom meeting for my internship. So
Okay.
but I will have the material. So next Tuesday morning, we can go over today and Thursday's material.
Cool. Cool. Thanks. And Chris, if you could just send out a reminder through
Yeah, will do.
Canvas about that, that would be awesome. So thank you for that.
Yeah, will do.
Yep. So chapter 12 is all about learning how to count. And that's what we're going to talk about today. And, you know, we all know how to count 1, 2, 3, 4, 5, but what about counting things that are a little more complicated? That's what we're going to talk about today and Thursday. We are skipping chapter 13, which is probability. And you guys should be glad because probability is often a section that gives students a lot of difficulty. And then next week we'll be doing chapter 14, which is statistics. Okay. And that statistics section, pretty important stuff. There's a big chunk of your final exam that will center around the statistics concepts. So that's what's coming. Just as a reminder, or if any of you haven't been dialing into the Zoom calls, in the files section, if you click files to the left in that menu, there are a number of files. If you see Zoom notes right there, click on Zoom notes, and you will see the notes that I create. Today's lesson notes are right there in PDF form. Now I may go through and make some changes to them as I'm doing the presentation, and then any changes that I make to these Zoom notes, I will reload them after class. All right, so we are going to jump right into the lesson. I am going to open up section 12.1 notes. Hopefully you guys can see, it says 12. Do you see 12.2 or 12.1? What's showing up on your
12.2.
12.2.
Yeah, I don't know why I clicked on. How about now?
12.1.
Yeah, you got it.
All right.
12.1.
Cool, thank you. Okay, so introduction to counting methods. All right, this is what we're going to talk about today. And again, folks, counting is not as simple as you might think it is when we get into more complicated situations. I mean, we count things every day. If you're working out, you probably count the number of reps that you're doing at the gym. We all need to be counting our calories right now because you don't want to gain the quarantine 15. You know, we had Easter weekend, we had our big dinner and everything, and I stepped on the scale this morning and I was about a pound over my ideal weight for right now. So I'm being a little more strict. I'm counting my calories. Some of you are sitting there counting the number of minutes until this class is over. And I'm not offended by that. But we count things every day. However, how do we count things when the numbers get a lot bigger? Okay, and so what I want you to do is I want you to open your books to page 621. I did not think to have the ebook open. That was my bad. I don't have that open. So I'm going to count on you to look at page 621 in your books, which you should all have. And there are a couple of different ways that we're going to talk about for counting methods, ways to count things. The first one is simply systematic counting or listing things. And this is easy to do when we have just a few items that we're trying to count. So for example, how many different ways can we flip a coin? Well, that's pretty simple, okay? You know, if we have a coin, we know that there are two sides, a heads and a tails. So there's two ways that we can count the outcome of flipping a coin. Or if we talk about rolling a single die, a six-sided die, you roll it, you could get a 1, 2, 3, 4, 5, 6. These are very simple ways that you can count things. Even something with a little bit larger number of items, like a deck of cards, has 52 items in it. So if you draw a card randomly from a deck, you know there are 52 ways that you can get a different outcome. So you can count 52 outcomes. Or if you have a newspaper staff and there are 5 people on the staff and you've got to pick an editor, somebody to be the head editor, well, there are 5 people, so there are 5 ways that you can choose that editor. Pretty simple. But what happens when we get into things that are a little more complicated? Well, if you turn to page 622, the next page, let's look at example number 2. And it's not super complicated, but it takes a little bit more thinking here. So in example number 2, we've got an organization that is going to hold a fundraiser, okay? And there are 4 different types of fundraisers that they could host. They could do an online auction. They could do an air hockey tournament. They could do a road race of some sort, a themed road race, or they could do a karaoke night, okay? So there are 4 different things that they can do, and they're going to choose 2 of them, okay? They're going to choose 2 of them. How many different combinations of fundraisers could they come up with? Well, in an event like this, you want to be very careful, and again, the key word here is systematic in the way that you count the number of ways that these could be grouped in 2s. You don't want to just start jumping all over the place. You want to start with a system, if you will. And so in the book, what they show us is they're going to say, okay, what if we do an online auction as one of them? So if we do the online auction, then we could also do the air hockey tournament, or we could do the themed road race, or we could do the karaoke night. So you've got the auction and the other 3 options, okay? Or what if you say, well, we're going to do the air hockey tournament. That's a given. Then we could also do the auction. We could do the themed road race. We could do the karaoke night. And so you need to understand that what we're doing is we're not jumping all over the place. We're being very systematic. We're starting with one outcome and listing the other options that could go with it. And we do that very carefully. And you'll notice in the book that if you do that, there are 12 ways to select the fundraisers for the year. There are 4 different fundraisers. You're selecting 2. And if you list all the different ways that it could be done, there are actually a total of 12. Now, what's important to understand about that is that doing the auction and the air hockey tournament, the order matters there, okay? Auction and air hockey tournament is not the same as air hockey tournament and auction, because it's when you're scheduling it in the year. So there are actually 12 different ways that you can schedule those events. Are there any questions about that? Again, I'm looking at the share screen, so if somebody has a question, just unmute yourself and go, hey, Mr. Becker. And Chris, of course, interrupt if you want to expound on anything that I might have overlooked. Okay. The next, hang on a second here. It's getting a little warm in my office, so I had to turn on the fan. All right. The next method that we can use for counting the number of ways that something can happen is something called a tree diagram. And these are very useful, especially if you have, less than 20 possible outcomes that you're counting. So here's our scenario. And this, by the way, is example 3 at the bottom of page 622. I've kind of transferred it over here, but I want you to understand what's happening. So we're flipping 3 coins. Okay, they've actually identified a penny, a nickel, and a dime. Doesn't really matter. We're flipping 3 coins. Of course, I got a quarter for all 3 of these images. Again, it doesn't matter. And we want to know the number of different outcomes that we can get when we flip 3 coins. So we already talked about this in example 1 of the previous on the previous page. If you flip a coin, there are 2 possible outcomes. So here's our first toss of the coin. We could get heads or tails. Now, when we flip a coin the second time, we could again get heads or tails. But remember, we're counting the number of outcomes across all 3 tosses. So you could get a heads on the first, and then a heads on the second, or you could get a heads on the first and a tails on the second. All right? Or if you got a tails on the first, then you could still get heads on the second, or you could get tails on the first and tails on the second. Okay, so that's the possible outcomes when you've tossed 2 coins. So you can see where this is going. So then if you toss a coin 3 times and you got heads on the first, heads on the second, you could get heads on the third, or you could get tails on the third. So This outcome is heads, heads, heads. And this outcome is heads, heads, tails. It is different. These two outcomes are different from one another. So there are two different possible outcomes. Or you could have gotten heads on the first, tails on the second, and then heads on the third. Oops. Or you could have gotten heads on the first, tails on the second, and tails on the third. So heads, tails, tails, and heads, tails, heads are different. So again, you can see where this is going. If you got tails on the first and heads on the second, you could get heads on the third or tails on the third. And then tails, tails, heads is a possible outcome, as is tails, tails, tails. So how many different possible outcomes are there when you toss a coin 3 times? Well, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes when you toss a coin 3 times, or when you toss 3 different coins. Doesn't really matter. Okay, so this is a tree diagram, and we're going to look at another tree diagram in a little bit. But sometimes a tree diagram could get really messy and too cumbersome. When you get too many different options, a tree diagram is not ideal. So take a look at example 4 at the bottom of page 623. And in this case, they're talking about rolling 2 dice. Okay, and when you roll 2 dice, of course, you could get a 1, 2, 3, 4, 5, or 6 on the first die. And then you could get a 1, 2, 3, 4, 5, or 6 on the second die. If you look at that image at the bottom of page 623, you'll see that there are actually, if you count them, 36 different possible outcomes when you roll 2 dice. And if you were to roll 3 dice, there would be another 6 at the end of each of those branches, which would be 216 possible outcomes and so forth. You just keep multiplying by 6, and you're going to get the number of outcomes each time you add a die into the rolling equation, if you will. If you've ever played the game Yahtzee, and for those of you who don't know Yahtzee, it's a dice rolling game. You have 5 dice, and the goal is to roll them and make patterns, and the best roll is to get 5 of the same number on a die. So 5 1s or 5 2s or 5 3s and so forth. Well, the chance of doing that is 6 times 6 times 6 times 6 times 6. It's very unlikely that you would get that in one roll. We're not going to go into probability. We're simply talking about counting right now, so we don't have to worry about that. But anyway, if you look at the top of page 624, you'll see a table that actually shows all the number of ways that you can roll 2 dice. You can get a 1 1, a 1 2, a 1 3, 1 4, 1 5, 1 6, and so forth. Okay, so there are actually 36 different possible outcomes when you roll 2 dice. And now I know that somebody is thinking out there, well, wait a minute. That kind of makes sense, because if there's 6 ways to roll the first die and 6 ways to roll the second die, and if you multiply 6 times 6, you get 36. So that makes sense that there are 36 different ways. And that's very observant if that occurred to you. And that actually will tie into section 12.2, which is the fundamental counting principle, which we will talk about in a few moments. Okay? So don't drop that thought if it occurred to you. Now, excuse me, in the coin flipping and the dice rolling situation, we're allowed to repeat things. But what if we have a situation where we are not going to allow repetition? And I created this problem. This is not in your book, so you'll definitely want to print out the notes if you want to have this as something to refer to. But I used an example with my 3 daughters that are living at home with us in quarantine. Sarah, Faith, and Rachel. These are my daughters' names. And they've agreed to cook dinner on Monday, Tuesday, or Wednesday night during quarantine. But if Sarah cooks on one night, she's not going to cook on either of the other 2 nights. That just makes sense. We're sharing the load around here. So how many different ways are there for these 3 ladies, my daughters, to organize the cooking schedule? All right, so I've created a tree diagram here. And repetition is not allowed. So in other words, if Sarah cooks on Monday, she's not going to cook on Tuesday or Wednesday. And the same for Faith and Rachel. Okay? So here's the tree diagram. If Sarah cooks on the first day, and I'm using S, F, and R for the 3 girls. If Sarah cooks on the first day, in the second column, this represents the first day. This represents Monday, and then this is Tuesday. And then over here, this would be Monday, Tuesday, Wednesday. So If Sarah cooks on Monday, then only Faith or Rachel could cook on Tuesday. Hopefully that makes sense. And of course, if Sarah cooked on Monday and Faith cooked on Tuesday, that means that Wednesday is reserved for Rachel. But if Sarah cooked on Monday and Rachel cooked on Tuesday, then Wednesday is reserved. Oops. I was just trying to highlight Faith. You get the idea for Faith. Okay. So one possible outcome is Sarah on Monday, Faith on Tuesday, Rachel on Wednesday. Another one is Sarah on Monday, Rachel on Tuesday, and Faith on Wednesday. And then we just play that out. So if Faith cooks on Monday, then it could be Sarah on Tuesday or Rachel on Tuesday. And then whichever one of the girls did not cook on Monday or Tuesday picks it up on Wednesday. So this is an example of a tree diagram where repetition is not allowed. Okay. And you can see the number of different outcomes that are possible. Now that's all we're doing is we're simply trying to figure out what that number is. We're simply trying to count the number of different ways that we can create a cooking schedule. And there are clearly 6 of them. Sarah, Faith, Rachel, or Sarah, Rachel, Faith, and so forth. You'll notice that each of the girls appears twice on the Monday. And then if you look, each of the girls could occur twice on the Tuesday. Faith, Sarah, Faith, Rachel, or Rachel, Faith, Sarah, and so forth. Okay. So that gives us 6 different ways that we can arrange the cooking schedule while we're in quarantine. So again, to recap very briefly in section 12.1, we're simply looking at ways to count different possible outcomes when it's a little more complicated than just 1, 2, 3, 4, 5. All right. So I have assigned some homework in 12.1 that I would encourage you to practice online. Some of you have been practicing the homework. It does show up for me that you do that. Some of you have not. I'm not, I'm not judging anybody, but I will say that there were a couple people who probably could have done better on the test if they had practiced some of the homework problems. So I would encourage you to consider that. So now we're going to move into section 12.2, and I'm going to hopefully share that. That is still 12.1. Hang on a second here. All right. Are you now seeing 12.2, Chris, the fundamental accounting principle?
Yeah, we can see it.
Thank you, Jason. Let's build a Subway sandwich. You guys see that? All right. I'm going to presume that you can. Now, nearly everyone, if not everyone in class, has gone to Subway. All right. I like to do this problem in a little more interactive fashion, but it's a little more difficult given our current circumstance. So we're going to do the best we can. So when you walk into Subway, and by the way, my daughter Faith works at Subway, although she's not working now for obvious reasons. But when you walk into Subway and you walk up to the counter and they say, "Can I help you?" the first question is always going to be, "What kind of bread do you want?" That's the first thing that that they grab out of the oven. And so you tell them what kind of bread you want, honey wheat or a white or Italian, or I want a wrap. Could even be I don't want bread, I want a salad. That's an option. But the next thing they ask you then is, how big? Do you want a foot long? Do you want a 6-inch? Once you're past that, they ask you what kind of meat do you want? And for meat, we're going to use just a very broad term, because if you wanted a veggie, of course, that would be no meat. But then there's meatball, and there's chicken, and there's ham, and there's turkey, and all of the different options. And once you've told them what kind of meat you want, then we move to the cheese. What kind of cheese do you want? After you've chosen your bread and how big a sandwich and the meat and the cheese, they ask you one very important question. Do you want it toasted? Okay. And there's only 2 options there. You either do or you don't. You want it toasted or not toasted. So there's 2 choices there. So we'll come back to that. After it is toasted or not toasted, then they ask you about veggies. And then usually the last thing they ask you is, what kind of condiments do you want? I use the word sauce because I was running out of space on the line, and condiments would have gone over to the next line. But condiments are going to include your mustard and your mayonnaise, your oil and vinegar. It's also going to include your salt and pepper, It's going to include things like Parmesan cheese and so forth. So, and then of course they do ask you, do you want to make that a meal? I didn't include that option here because again, I was running out of space on the page. But anyway, so the question is, how many different kinds of sandwiches, how many unique kinds of sandwiches could we make at Subway with these options? And a tree diagram would make absolutely no sense, as you're going to find out very quickly. Okay, so here's how we proceed, and this is going to lead us to the fundamental accounting principle. So let's just pick some numbers for bread. Anybody want to throw out, and if anybody is muted and you want to participate, unmute yourself. Throw out a number for the different kinds of bread choices you would have at Subway. Anybody?
Christine says 5.
Christine says 5. All right, so that's a good number, Christine. Whoops. Hang on a second here. So 5. So we're going to say there are 5 options for bread. Cool. Now, how many choices are there for the size of your sandwich?
Technically 3.
And why is that, Chuck?
Well, because, my sister has like a 3-year-old son. She usually goes in and then gets a little 3-inch for him as well.
Exactly. Yep, you're exactly right. That's one that a lot of people don't normally remember. They always think about 6-inch and foot long, but there is a kid size. So good, Chuck. We'll go with 3. How many meat options are there?
Does egg count as a meat?
Can you get, well, I guess you can get a breakfast sandwich there. Sure, you can count egg if you want an egg sandwich. Sure.
Should we only count the yellow egg and not the white egg, because white egg is not really egg, it's just stuff?
You can count anything you want to. There's a lot of meat choices. Anybody want to throw out a number?
I'm going to say 8 sounds like a good number.
8 sounds like a good number. I'll use 8. I will tell you that there's probably more than 8 if we really tried, but we will stick with 8. How about cheese types? Any thought on different kinds of cheeses? Oh, Jason says he's getting hungry. Yep. Okay. So Rena says Parmesan. That's one kind of cheese. What else is there?
Pepper
Pepper jack.
Provolone.
Provolone's my
American,
choice. American.
The shredded stuff.
Sure. Shredded.
They don't have Swiss, and I have been writing a lot of angry letters to them about not having Swiss. But
Are you serious? Have you really written a letter about Swiss cheese?
yes, I've also written letters of the fact they got rid of my favorite bread, the Hearty Italian.
Really?
Yeah, it was
Wow.
Hearty Italian. They had it a few years ago. It was my favorite bread, and they discontinued it.
I did not know that we had a Subway activist in our class, but that's awesome.
Mm-hmm.
Well, we're up to 5, and I'm going to say 6, just because I want to use a slightly different
6,
number.
yeah.
Can we go with 6? Does that work for everybody?
Yeah.
Okay. Now, how many options do you have for toasted? I already answered this.
Technically 3, because there's not toasted, and then they also have this thing called warm.
Really?
Yeah.
Well, I'm gonna go with 2 simply because I want a different number than 3, because I'm trying to keep things a little different. But that's interesting. I didn't know that you could get something warm. That actually doesn't sound all that appetizing to me. But anyway.
It doesn't.
All right. Yep. How about veggies?
I would say like 12 or 15.
I'm going to go with 12. That's your first number. I'll go with 12. I mean, and different Subways have different things. I've been into Subways where they don't have spinach. I've been in Subways where they do. I've been in where they have red peppers and others that don't, and so forth. So I'm going to go with 12. That's a good number. And then sauces. Ahmad said 10. You know what? I'm going to use 10 for the very last one. All right. I'm going to use 10. We can probably come up with more, but when you think about the sweet onion teriyaki sauce is my favorite. And then there's the light mayonnaise and the regular mayonnaise, and there's mustard and then all that stuff. We'll go with 10. Okay. So what we've done is we've listed the number of different ways or number of different choices we have for each of these options. Now the question is, how many different sandwiches could we make with that? Well, here's what I want you to imagine. If we were trying to do a tree diagram here, okay, if we were trying to make this a tree diagram, you would have 5 branches for the bread, and then off of each of those 5 branches, you would have 3 branches for size. Off of each of those 3, you would have 8 for meat, and then off of each of those 6 for cheese. Can you see how that this is getting out of hand, right? Using a tree diagram to try and figure out how many different options there are for Subway sandwiches is insane. But there is something that we can do. It's called the fundamental counting principle. The fundamental counting principle says that if you want to complete a series of tasks, and that's what we're doing when we go to Subway. When you go to Subway and you stand in line, the person behind the counter is asking you to complete a series of tasks. They're saying, what kind of bread do you want? How big a sandwich do you want? What kind of meat? What kind of cheese? Do you want it toasted? What kind of veggies? What kind of sauce? You're completing a series of tasks, okay? And if the first task can be done a certain number of ways, and the second task another number of ways, and the third task another number of ways, and so forth, the total number of tasks, the series of tasks that you are completing can be done in A times B times C times D times E times however many options there are ways. In other words, what I'm saying is that if you are trying to complete all of these tasks and you want to know how many different ways there are to do it, you simply multiply all of these numbers together. And I'm going to ask while I'm putting this in there if there's somebody with a calculator who wants to multiply all these together and tell us how many different ways there are to complete this task. In other words, how many unique sandwiches can we make here? I could do it, but I'm being lazy, so hopefully somebody out there is multiplying these together. 7,200. Okay, let's see here. 172,800. I got that from Christine and from Chris. So that means there are 172,800 unique sandwiches based on the options that we have presented right here. Okay? Does that make sense? Hearing no objection, let me put it into a much more simple and concise way than this kind of formal explanation right here. Very simply put, if you're trying to complete a series of jobs and there's a different number of ways of doing each part of the job, just multiply all of the different ways you can complete each task together, and that will give you the answer for the number of different ways it can do. And Charles wants his with a side of Corona. All right. Yes. Well, oh, I probably told you guys
My
this
friend
joke.
works at Subway.
Oh, does he? I don't
My
think you
friend
can buy
works
beer.
at Subway and he said that.
Yeah, I don't think you can buy beer at Subway.
No,
Well,
like
you know
he
what?
was saying when they came out, he's like, "Hey, you want this with coronavirus?" And he's like, and I'm like, "Do I have a choice?" He says, "No."
Yeah. Wow. Well, anyway, let's go ahead then and take a look at a couple of examples here. Let's go back to that problem we talked about a little bit ago. Remember the problem in the previous section where we were doing a fundraiser and we had the option of doing an online auction and let's see, a themed road race and what were the other options? Air hockey tournament and karaoke. Remember that problem we did? Let's go back and revisit that, okay? Now in section 12.1, what we did is we used systematic listing to say, okay, if we do the auction, then we could do the air hockey tournament or the auction and the road race or the auction and karaoke night. So there's 4 different ways we could do it, okay? And we use that listing method, nothing wrong with that. But the fundamental counting principle actually makes it so much easier. And I'm gonna show you why. Because if we're doing the fundamental counting principle here and we have 2 tasks, okay? In this particular problem, we have 2 tasks. We are picking a first choice, first fundraiser, and then we are picking a second fundraiser, okay? How many ways are there to choose our first fundraiser? Anybody? How many options do we have for our first fundraiser? I know you're out there. I see your faces. Anybody want to hold up their fingers and show me?
6,
Why are there 6?
because there are. Oh wait, hang on. Was that a examples?
What are the fundraising options?
Oh, there's 4. I'm sorry.
There's
I was on the
4,
wrong-
right? That's okay. So there's 4 options. We could do the online auction, we could do the air hockey tournament, we could do the themed road race, or we could do the karaoke night. Okay, so let's go back to that here momentarily. Okay, so there are 4 options for that first fundraiser. Okay, so once we've chosen our first fundraiser, how many fundraiser options are left for us to choose from for our second fundraiser? If we had 4 choices for our first and we picked one of them, how many are left for us to choose from for our second? Yes, exactly. A couple people, Ahmad and Jillian, said 3. Exactly correct. Okay. So that means that there are 3 choices for our second fundraiser. Now, if you remember in the original question, we were simply asked how many different ways are there to do these fundraisers, and we listed them systematically. But now that we understand the fundamental accounting principle, we don't have to list systematically. We can say, well, if there's 4 ways to choose the first fundraiser and 3 ways to choose the second fundraiser, then there's a total of 4 times 3 or 12 ways to create 2 fundraisers. Okay. We just have to create slots, and that's what we talk about. We're going to talk about in a little more detail down here. Filling slots, that's essentially what we're doing. Okay. So I'm going to skip over example 3, and let's jump down to example 4 on page 631. Now, I want you to pay very careful attention to this example. And I want to remind you, I know we haven't been together in person in a while, but when I say something like pay very close attention, or this would be a good problem for you to know how to do, I'm not just talking to hear my own voice. All right. So example number 4 is counting dinner choices using the fundamental counting principle. All right. So let's say that you go to a restaurant. I'm sure some of you, remember what it's like to go to a restaurant. Haven't been to one in a long time. Although I had to take my wife yesterday to the hospital for an MRI. Nothing serious. She just needed her hip. Her hip has given her some problems, so she had an MRI, and so she was in there for a couple hours. And so I'm justifying this. I shouldn't probably even be telling you this because people will say, Mr. Becker, I can't believe you were out in public. But my wife had to go to the hospital for an MRI. So I drove over to Starbucks. Their drive-thru was open, and I got myself a nice socially distant cup of coffee. And it was the first Starbucks I've had in like 3 weeks. So it was wonderful. But anyway, so please don't report me for being out and about. I had a good reason. Anyway, in example number 4, you're going to a restaurant and you've got different meal choices. Okay, you're creating an entire meal and you're going to select an appetizer, a soup, an entree, and a dessert. Okay, so how many different ways are there to select your meal? Well, again, it tells us in the problem that, let me give myself one more line. It tells us in the problem that we're selecting appetizer, a soup, an entree, and a dessert. And it tells us the number of ways we can choose each of these. It tells us that there are 4 different appetizers. And it tells us that there are 3 different soups. and it tells us that there are 6 different entrees, and it tells us that there are 5 different desserts. Okay, so by the fundamental counting principle, if we want to know the total number of different meals we can choose, we simply multiply these options together. And I think I can probably do this in my head. Let's see. 4 times 5 is 20. 20 times 3 is 60. Times 6 equals 360. I guess it's probably listed there. Equals, yes, 360 different meals. Again, the fundamental counting principle, we're just filling slots, which is the concept that I want to reinforce here. You take the number of tasks that you need to complete and you create a slot for each of them, and then you write in the number of ways you can perform them, and then you multiply. So let's take a look, and this will be our final example, folks. So we'll be done in the next 10 minutes. Hang with me, those of you who are still here. Let's look at example 5 on page 632. Now, we've all been in this situation where we've had to put in a locker combination, whether you have a locker at the gym or if you hearken back to high school and you had a combination lock in high school. So let's embrace the idea that you have a locker at the fitness center and you've got a 5-digit code. And of course, the digits are 0 through 9. Which is, by the way, a total of 10 digits. Sometimes people think, oh, there's 9 digits. They forget that 0 is a digit as well. So how many different codes are possible if, and we've got 3 different problems, and I actually threw in a 4th problem. So how many different codes are possible if any digits can be used in any position and repetition of digits is allowed? Okay, so in other words, we've got 10 digits, okay? So we've got 10 choices for the first one. We've got 10 choices for the second one. We've got 10 choices for the third one. We've got 10 choices for the 4th number. And we've got 10 choices for the 5th number. Okay? So how many different choices are allowed? How many different locker combinations are there? 10 times 10 times 10 times 10 times 10. And of course, if you multiply, exactly right, 100,000. There are 100,000 different options for, oh, by the way, I keep forgetting to look at the chat. So thank you for participating, Christine, Jillian, Jordan. Thank you for popping answers up there as well. Yes, there are 100,000 different possible locker combinations. If you can put any digit in any position and repetition is allowed. So the first digit could be 0. 0, 0, 0, 0, 0 is an option. By the way, it's not the best, most secure code, but it is an option. Okay. Now, what if instead of every digit can be in any position, what if the first digit cannot be 0? It says in part B, what if the digit 0 cannot be used as the first digit, but otherwise any digit can be used in any position and repetition is allowed? So the first one cannot be 0, but there are still 9 choices, okay? And then whatever you picked in the first position, you can use again. So if you used a 1 over here, you can use a 1 here. The only restriction is that you can't have a 0 here. So then we still have 10. We're filling slots like so. So exactly, thank you, Ahmad. So now we have 90,000 different ways that we can have a locker combination if 0 cannot be in the first position and repetition is allowed. Let me pause for a minute. Are there any questions? Is this making sense? Are we okay with it? Again, I'm going to assume that your silence is your affirmation that you understand. All right, so let's look at letter C. What if any digits can be used in any position? So we're taking off this restriction. You can put a 0 here, but you're not allowed to repeat. Okay, hang on just a second. Let's go back. Judith says she's confused on how we got the 10. Which 10 are you confused about, Judith? Up here in letter A, is that what you're talking about? Okay, all right. So the reason we got 10 is because there are 10 different digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a total of 10 digits, all right? 0 is a digit, just like 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if you count those up, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different digits. No problem. Okay, she got it. All right. And for those of you who are wondering if Judith and I are just, telepathic or whatever, we were in the chat. So if you don't have the chat box open, she was messaging me there. So feel free to do that. All right. So now let's go back down to letter C. Now in letter C, we can use any of the digits in any position. So this previous requirement here is not a requirement anymore. So we could put a 0 in the first blank or anywhere, but we're not allowed to repeat, okay? We're not allowed to repeat. So we still have 10 choices for the first digit, but whatever number we used in the first slot, we are not allowed to use again. So let's say that we used a 5 in the first slot. That means that we can use any number other than 5 in the second slot, so we still have 9 choices remaining. So let's say we used a 4 in the second slot, so we've used a 5 and a 4. So now, for the third slot, we only have 8 choices remaining. Let's say we used a 3, so we have 5, 4, 3. So now in the fourth slot, we only have 7 choices remaining. And then in the fifth slot, of course, we would have 6 choices remaining. And Ahmad says that that is 30,240. I will assume he is correct unless, I guess I could look at the book, couldn't I? Yes, it is correct. Thank you. Thank you very much. Okay, so these 3 examples are example 5 on pages 632 and 633. Now I threw in a bonus one. I want to talk about this because I want you guys to think a little bit. So what if the first number must be an odd number, okay? And the last number must be an even number, and we are not allowed to repeat. So let's think about that. Okay. So we're going to work on the first slot. And I was trying something here. Hang on a second. There we go. So we are going to fill the first slot and the last slot. That's what we're going to do initially, okay? Hopefully that makes sense. So how many ways are there to fill the first slot if it must be an odd number? Yes, Jillian says 5. Very good. So there are 5 ways to fill the first slot. How many ways are there to fill the last slot? There are also 5 ways to fill the last slot because the last slot must be an even number. 0 is an even number. So we're going to put 5 in that last slot. Okay. Ahmad, you said 9. Are you okay with why we have 5 in the first and the last slot? Because they have to be odd and then even? Does that make sense? Okay. Okay, cool. All right. So hang with me here. Repetition is not allowed. Okay. So whatever number I used in the first slot and whatever number I used in the last slot, those numbers are no longer available. So how many digits are left that we can use for the middle 3?
4.
8. Well, yeah, because we can use any numbers. They could be odd or even, right? So let's say, hang on a second. Let's say that we use the number, the first number has to be odd. let's say we use the number 1 in the first slot, okay? Stop it. Hang on a second. Let's say we use the number 1 in the first slot. This is the actual number. This isn't the number of ways something can occur. And let's say we use the number 2 in the last slot. So we used 1 and 2. So that means that there are any other numbers besides 1 and 2 that can be used. So yes, I'm seeing a few people put in 8. There are 8 ways to choose the second number. Okay. How many ways are there to choose the third number? 7. That is correct. And how many ways are there to choose the third number? Yes, 6 is correct. So then the total number of ways that we can choose, if the first number has to be odd and the last number has to be even, the middle numbers can be anything, okay? When we multiply that together, Ahmad is telling us that that is 8,400. I am going to believe him. Christine confirms it, and so does Jillian. Actually, Jillian said it first. So there are 8,400 ways that we could do that. If the first number had to be odd and the last number had to be even, we are not allowed to repeat. Okay? Let me ask the same question. Let me throw a little curveball here. Let me ask the same question. What if repetition is allowed? Okay? So let's go down here for a minute. We'll take out these middle numbers for a minute. What if we were allowed to repeat our choices? Okay? So the first number still has to be odd and the last number still has to be even. How many choices would we have for this number right here?
Will be
If
10.
repetition, it would be 10. Very good. That is correct. And how many choices would we have for the next one?
Also 10.
Also 10. And for the third one, it would also be 10. So if repetition is allowed, then we would get a total of, I'm seeing a couple people tell me 25,000, and that looks to be correct, okay? Just notice the difference between these two, and I did just throw this in there. I will post this revised thing in the notes. Okay, so notice the difference between repetition being allowed and repetition not being allowed, okay? It's very important when you're doing a problem like this that you read it to determine whether repetition is allowed or not. All right. So let me pause right there. Does anybody have any questions relative to 12.1 or 12.2?
Yeah, I actually do. So for number or letter D, how did we get 8, 7, and 6?
Okay. Who's talking? Because I can't see the screen. Is that Christine?
Yes.
Okay. Hey, I recognize the voice. That's pretty cool. Okay. So Christine, you understand how we got the 2 5s, right?
Yes.
So those numbers have already been used, and we are not allowed to repeat. Does that make sense so far?
Yeah.
So those 2 numbers are thrown out. Okay.
Okay.
Now, this could be, the first number could be 1, 3, 5, 7, or 9. The last number could be 0, 2, 4, 6, or 8. It's one of those. So whatever numbers appeared in the first and last slot are thrown aside. We cannot use them anymore. So that means there are still 8 digits left that we could use. Okay. Now, the middle numbers, there's no restrictions on these 3 numbers. Okay. The only restrictions were on the first and the last number. And the other restriction is that we're not allowed to repeat the first or the last number. So let's go ahead.
Okay, so if we used all the evens and we used all the odds already, then how are we getting the rest?
Well, you're not using all of the evens and all of the odds. This is the number of different ways that an even or an odd can occur.
Okay.
So for example,
oh yeah. You're right. I got it. Okay. Okay.
Does that make sense?
Yes.
So you're good.
Yes.
Okay. Okay, great. Great. Does anybody else have a question? Anybody? Okay. Well, So then what I'm going to do is I see a few people have checked out. That's okay. What I'm going to do is I am going to save and upload this to YouTube, and I'll post the link to the video chat in case you want to go back and review it. If you have friends who are in the class who were not here today, you can let them know that they can go to the video chat. I'll do the same. I just want to remind you that on Thursday we'll be doing section 12.3. There's nothing wrong with working ahead, looking ahead in your book, or working on the problems ahead of time. And other than that, be mindful of the fact that you have a test 2 weeks from today, the 28th. You'll have another one of those online tests. I will be posting in the next few days or so a set of review problems for the final. I know it's early, but I've been working on them because I'm coordinating all of the M100 classes for all of our instructors. And so I'm in addition to worrying about you guys, I've got like 6 other instructors who are teaching M100 classes that I have to get the content to them as well. So I've been working on that. So I will post the review problems for the final exam, probably, well, maybe today. I'll probably spend the rest of today trying to work on that kind of stuff. Last opportunity. Does anybody have any questions?
When I came in earlier, you were talking about the final exam. Could you say what you were saying earlier about it?
Yeah, the final
Sorry.
exam is going to be a written exam, unlike the 2 online tests that you're taking. On the day of the scheduled final, which I'll give you all that information, basically what I will do is I will post the final exam in the file section of Canvas. You will need to print it out and do the exam on paper, and then you will need to scan it and send it back to me. If you don't have a scanner, then you will need to probably get really good quality pictures with your phone and email me those images so that I can print them out. That's not the ideal choice, but we're doing the best we can with what we have. So that final exam, I think it was initially scheduled for like May 7th is the date that sticks in my head, I think.
It was like it's in Canvas, it's saying like the Thursday, but I think you said it was like originally the 8th, I think. Or not the 8th. Yeah, maybe. I think
May
maybe
8th?
Canvas is saying that the 8th, and then
It is
said
whatever the
7th?
Thursday. I guess I've got my phone right here.
Okay, so 7th, the May 7th would be Thursday.
Yep. Okay. So it will be that Thursday. So what'll happen is that at midnight, I'll post. Well, I'll probably do it the night before I go to bed. I'll post the exam, and you'll have that day to take the exam and send it back to me. It's not open-ended like you get, all sorts of time. You'll have a full day, which is, a lot longer than the 2 hours you would normally get in class. So you'll have that day to take the exam and get it back to me. And then I will spend that Friday, Saturday, Sunday grading the exams and posting your results. Okay?
Okie doke, thank you.
You're welcome. Anybody else? Okay, everybody. You guys stay healthy. Be smart. Don't go out and, hang out with all your friends. There's a lot of people who ended up getting sick from all the craziness of spring break. I'm just worried about, I'm worried about you guys. I want you guys to get done with this class because nobody wants to take it again. So anyway, all right, I am ending the recording at this point.